Okay, we will start Unit 13 by looking at expanding brackets. So when we expand brackets, we use what is called the distributive property. And when we talk about distribute, you might think of something like distributing flyers. So that means everybody's going to get one. So when we distribute multiplication over addition and subtraction, it means that the number in front of the bracket is going to be distributed by both terms inside the bracket. So we would multiply a times b and get ab, plus we will multiply a times c and get ac. And that also works for subtraction. So we would multiply a times b and get ab, minus a times c and get ac. So this is called the distributive law. And this is how we expand brackets. So when I see a question like 2 times x plus 1, I'm going to distribute the 2 across both terms inside the bracket. So we will do 2 times x is 2x plus 2 times 1 is 2. Likewise here we have a 5. We're going to distribute the 5 across both terms in the bracket. So we will multiply 5 times 2x is 10x plus 5 times 3 is 15. So this process is called expanding. And expanding means to multiply. Then after that, we look to see if we can collect like terms. Well, in all these questions that we've done so far, there aren't any. 2x and 2 are not like terms. These are similar questions. We just have to be careful of signs. So I'm going to distribute the negative 3 across both terms. So it's negative 3 times x is negative 3x. And then be careful, we have a negative times a negative, which gives us a positive. 3 times 4 is 12. In the next question, a negative in front is representing a negative 1. So if you want to write the 1, that's fine, if that makes you understand it easily. So I'm multiplying negative 1 times 4x, so that's negative 4x. And then a negative 1 times a negative 7 gives us a positive 7. So just be careful of signs when we are multiplying. Also be careful of exponents. We're going to distribute x squared across both terms. So this is like a 1, x squared. So 1 times 2 is 2. Remember, when we are multiplying exponents that have the same base, we can add the exponents. That's sort of the shortcut. So remember, x squared times x squared is going to give us x to the 4th. And then we have a 1 times negative 3 is negative 3, and then we have an x squared. In this question, we have a negative 3 times a times a 2. I always like to do the numbers first, so numbers, then letters. So negative 3 times 2 is negative 6. N, which is to the power 1, times n squared gives us n to the power 3. Then we have a negative 3 times a negative 5 is a positive 15. You can use your calculator if you're not sure. And then we have an n times n is an n squared. Now you notice in all these questions that once we expand, okay, so 2x to the power 4 is not a like term with 3x to the power 2 because the exponents are different. So once we've expanded, and that's the multiplying part, we look to collect like terms. If there aren't any, then we are finished. Okay, then we'll move on to adding and subtracting polynomials. So the first thing that we always want to do is remove any brackets. So in this first bracket, there's not anything in front of the bracket. I mean, there's a 1, but that's really not going to change anything about the bracket. So we can remove the brackets. And likewise in the second bracket, there's just a 1 in front, so we can just multiply all those terms by 1, which isn't really going to change much. Then we want to collect like terms. So remember that like terms have to be exactly the same variable with the same exponent. And all we do is we add or subtract the coefficients. The variables don't change when we add or subtract. So sometimes it's a good idea to underline like terms. So this is x to the power 3 and that term. So I'm going to add the coefficients. We have 3 plus 1 is 4. And x to the power 3 does not change. The variables stay the same. So just think of it as adding things, right? I'm just adding how many things I have. Those things aren't going to change. Let's use a different color. So x squared, we've got 3x squared minus 2x squared. So 3 minus 2 is 1x squared. We have a 4x by itself, so just minus 4x. And then we have a plus 5 minus 4 is positive 1, plus 1. And then we're finished. x3, x2, x are not like terms, so we're finished. Okay, so let's remove brackets here. So again, there's only a 1 in front of the first bracket, so we can just take away those brackets. There's a plus 1 in front of the next one, so let's take away those brackets. And there's a plus 1 in front of that one, so let's take away those brackets. So really, these brackets are not really necessary. They're not serving any purpose. Okay, so like terms. I'm just going to erase this bracket here. I don't need that. So minus 3, minus 2x. Okay, so x squared, x squared, x squared. Those are like terms. So we've got 7 plus 1 is 8. 8 minus 2 is 6. We've got an x, and an x. Those are like terms. So we've got minus 1, minus 2 is minus 3, plus 3 is 0. So we don't have any x's. I'm just going to write a 0 for now. Then we have a minus 4, a minus 3, and a plus 5. So that is negative 7 plus 5 is negative 2. So I don't really need the 0. So we'll just write it as 6x squared minus 2. Okay, if we have subtraction, so the first bracket just has a 1, so we'll just remove that bracket. So this is like multiplying everything by negative 1. So there we're going to apply the distributive property. So I'm going to do negative 1 times 3x3 is negative 3x to the power 3. I've got a negative 1 times a negative 8 is a positive 8x squared. I've got a negative 1 times a negative 5 is a positive 5x. And then I've got a negative 1 times a positive 6 is a negative 6. So just be careful of those signs. They're going to change. Okay. X to the power 3, x to the power 3. So 1 minus 3 is negative 2. Then we have 3x squared plus 8x squared. So that is 11. Then we've got 5x plus 5x is 10x. And then we have minus 4 minus 6, or negative 4 and negative 6 is negative 10. Okay, let's do this last one. So we've got a 1 in front of the first bracket, so nothing is going to change. We've got a negative 1 here, so negative 1 times 4x to the power 3 is negative 4x to the power 3. And negative 1 times a negative 11 is positive 11x. And then we've got a negative 1 times a positive 10 is a negative 10. And then we'll collect like terms. 6 and 4 is 2. We've got minus 2x, which is all by itself. Then we have a 8x and 11, that's 19. And then we have this minus 10 all by itself. And then we're done. Okay, so there are questions in the guide that you can try. Read through those questions and see if you can complete those on your own, and then check your answers at the back of the guide. Okay, after you've done those, we are going to kind of put them together. So we're going to expand and then simplify. So remember that expand means to multiply brackets using the distributive property, and simplify means to collect like terms. Okay, so we're going to expand the first bracket by multiplying each term by 4. So 4 times 2 is 8, and 4 times 3 is 12. Once that bracket closes, we're moving on to the next bracket. So the 5 belongs to the next bracket. So 5 times 3 and 5 times 8. So this is the expand step. Then we're going to collect like terms. Oops. Don't want that. Collect like terms. Okay, so what are like? 8x and 15 are like terms. So 13. And then minus 12y plus 40 are like terms. So that's positive 28y. We can't add 13x and 28y because they're not like terms. X is not the same as y, so we are finished. Okay, so let's expand. 3 times 4 is 12. X times x is x squared. 3 times 5 is 15. We have an x and we have a y. 3 times 3 is 9, and we have an x. So that bracket's finished. We're moving on to the next bracket. So negative 2 times 8 is negative 16, and we have an x squared. Negative 2 times positive 3 is negative 6, and we have an x. And then negative 2 times negative 5 is positive 10. So that is the expanding. And then let's collect like terms. So we've got 12x squared minus 16 is minus 4. Then we have 15xy is by itself. There are no other terms that have an x and a y. Then we have a 9x minus a 6x is 3x. And then finally, we have this 10 all by itself. And then we're finished. If I am putting this degree in order, this one has degree 2 because I have just an x and it has power 2. This one also has degree 2 because we have one x and one y. So 1 plus 1 is 2. This is degree 1. And then this is degree 0 because there are no exponents, so we don't have a variable. Okay, so you just want to put it in descending. So highest degree first. So it doesn't really matter if I have 2 that have the same degree. Okay, when we write our final answer, these are generally the rules. We like to write our answer in descending order. So that means biggest to smallest degree. So what is a degree? Well, a degree is the total number of variables that are multiplied within a term. So for example, if we had 4xy, x is to the power 1 and y is to the power 1, so 1 plus 1 is 2, so we'd have a degree of 2. If we had 2a to the power 4, that has a degree 4 because we just have one variable, which is an a, and it has power 4 all by itself. 3m squared n to the power 5 has a degree of 7 because we have 2 m's and 5 n's, so that adds up to 7. 17 has a degree of 0 because there is no variable, so we could say x to the power 0 because there is none. And then 3t has a degree of 1 because we just have 1t. So it'd be t to the power 1. Okay, so the degree is the total number of exponents added all up together. So it matters the order. And then there are some questions that you can finish, look at, and try on page C2 in your guide, and then make sure that you're checking the answers after you've completed them.